Hello, today we are working on lesson 5.1. It's the first lesson in chapter 5, and we are going to be working on solving systems of equations. And just to give you a little bit of a background, when we solve systems of equations, we're talking about two or more equations. Now for Algebra 1, we're just going to work with two equations, but when you get into maybe honors geometry or Algebra 2 and up, you will encounter three or more equations. Now, another thing about a system of equations is you have two equations. Each equation has the variables x and y in them. And your goal is to figure out what ordered pair you can plug in to both of those equations to make them true. Okay, so for example, on our notes, we have two equations right here. And I want to know which of these ordered pairs, when I plug them into this equation and this equation, will make them true. Okay, so when we talk about a system of equation and we're trying to find a solution or an answer to that system, what we're trying to do is we're trying to find an x value and a y value, which together create an ordered pair, that when you plug into each equation, it will make both equations true, not just one, but both equations true. Okay, so before I come up here and we go over the different possible solutions of systems, I want to show you what I was just talking about. Okay, so let's look at example 1. Get this zoomed in correctly. All right, so I'm going to take this ordered pair right here, 2, 1, and this is my x and this is my y, and I'm going to plug my x into where the x is and my y into where the y is. I'm going to do that for this equation, and then I'm going to solve. And then I'm going to do the same thing for this equation. Okay. So we have 2x, which is going to be 2. So 2 times 2 plus 3y, which is going to be 1. So 3 times 1 equals 12. So I plugged in my ordered pair. This is my x in the ordered pair. This is my y. Now, when I say solve, that means I'm going to combine all my terms on the left and see if it equals the right. So let's go ahead and do that. 2 times 2 is 4, plus 3 times 1 is 3. Does 7 equal 12? No. Now, because it does not work for the first one, I know that is not a solution. Okay, even if I did plug it in here and it did work, since it doesn't work for both, then it is not a solution. So I am going to go ahead and put that one as a no, and I'm going to try this second ordered pair. Okay, so I'm going to start with this first equation. I have 2 times my x. My x this time is 3/2 plus 3 times my y, and then my y this time is 3 equals 12. All right, so let's go ahead and solve this. 3 times 3/2 is 3. 3 times 3 is 9. And 3 plus 9 is 12, and 12 does equal 12. So this one is a solution to this equation. So now we need to figure out if it is a solution to this equation right here. So I take 3 times my x, which is 3/2, plus, oh, yes, actually it's minus, sorry about that. Minus my y, which is 3. And we're going to see if that equals 7. So 3 times 3/2 is 9/2. Okay, I can kind of already tell that this is not going to work. 9/2 is actually 4.5. And 4.5 minus 3 is 1.5. 1.5 does not equal 7. So I know that this is not a solution either. Remember, in order for an ordered pair to be a solution, it has to be true for both equations. So now I'm going to try the third ordered pair. So I have 2 times x. In this case, it's going to be 3. So times 3 plus 3 times y, which this time it is 2. And we're going to see if that equals 12. And you can already tell 6 plus 6 does equal 12. So that is a solution. But again, we have to make sure it is a solution for both. So I'm going to take this one and I have 3 times x, which is 3, minus y, which is 2. And we're going to see if that equals 7. 9 minus 2 equals 7. 7 does equal 7. So this one right here, 3, 2, is a solution for both of these equations. Okay, so our answer is right here. Okay, so whenever we're solving these systems of equations, you can always plug the ordered pair that you get back into both equations to see if they're true. That's a way to check your work. And we'll get to that in just a minute. So let's come back up here. Now, down here, we found one solution to a system. So right here, when you have one solution in your graphing, that graph is going to intersect at exactly 1 point. That means that you have one solution to that system of equations. That solution is represented by an ordered pair. Now, when you have only one solution, we call this consistent and independent. So consistent and independent. And consistent, meaning that it has at least one solution. Independent, meaning that each equation is independent from each other. They don't depend on each other at all to be graphed or to find a solution. Okay. Now, when you get down here, infinite number of solutions, what that means is that when you graph both of your equations, they're exactly the same. They lie on the same line. So for example, y equals 2x plus 3. You graph that, and then you realize after you've manipulated your second equation, oh, that's y equals 2x plus 3 as well. And so anytime you have two equations that are the same, that means they lie on the same line and they share every single point on that graph. That means that they have an infinite number of solutions. When you have an infinite number of solutions, we call it consistent. Consistent because it has at least one solution. And we call it dependent because in order for them to have infinite number of solutions, one equation depends on the other. They both have to be identical, okay? And then for the last one, no solution. Anytime you graph two equations on a line and you find that they're parallel, parallel lines, if you remember from pre-algebra, where you do a little bit of geometry, parallel lines never intersect. They're in that plane and they will never, ever touch. So anytime you graph two parallel lines, you'll notice that because they never intersect, they will not share a solution. So parallel lines have no solution, and we call this inconsistent. Inconsistent because they do not have a solution. And they are independent of each other, meaning they don't depend on each other for a solution. Okay. And you will need to know these vocabulary words right here for your quizzes and tests. Okay. So when you are graphing, okay, if you just flip over to the back page here or the next page, you're going to see a couple of graphs with a couple of equations and a line where it says solution. What we're going to do is we're going to graph these equations and we're going to see where they intersect, if they intersect at all, and determine their solution. And on the front of your notes are the instructions on how to do that. So one way that you can do that is you can determine the intercepts of each equation, the X and Y intercepts. The other way that you could do this is you can turn your equation into y equals mx plus b. And this is actually what we're going to be doing. We're going to be turning our equation into the slope-intercept form, y equals mx plus b. We will graph the y-intercept, we will plot the slope, and then we will determine our solutions. Okay, so let's go ahead and go to this second example. All right, so the first thing we need to do is we need to put both of these equations into slope-intercept form. And I just wrote this on the other side, but just in case, it's y equals mx plus b. Okay, so we're going to go ahead and do that with this one. In order to make this one, turn this one into slope-intercept, we have to subtract the x and move it over here. And we end up with y equals negative x plus 9. Okay. And then we graph this. So I'm going to start up here at my y-intercept of 9. And I'm going to plot my slope, which is a -1. Okay. And then I'm going to graph it. Give me 1 second. I need my ruler. Okay, so let's draw a line. And a lot of times students will say, oh, I don't need to draw my lines. I could figure out what the intersection is without drawing my lines. I still want you to draw your lines. Okay, so make sure you do that. Then we're going to go over here to the second equation. Again, I need to move x to the other side. So we end up with negative y equals negative x plus 5. Now there's a problem here, and hopefully you caught it. Our y cannot be negative, which means that we could do one of two things. We can multiply the entire equation by a -1, or we can divide every term by a -1. Okay, I tend to divide by a -1 just because that's how I've always done it, but you could do whatever you would like. So it's going to be x minus 5. And so now I'm going to graph this. So the first thing I'm going to do is plot my y-intercept, which is -5 on the y-axis. And then I'm going to graph my slope. My slope is 1, so it's a +1. So I graph it going up and to the right in the positive direction. Once I've seen that my lines have intersected and I've plotted at least 2 points, I can go ahead and draw my line. So now we have an intersection here. This intersection tells us the solution to both of these equations. And our intersection is at 7, 2. So my solution is written as an ordered pair, 7, 2. That means that when I plug 7 into the x and 2 into the y, it will equal 9. And when I plug 7 into the x here and 2 into the y here, it will equal 5. And this solution answers the system to both of these equations. Okay. All right, we're going to go ahead and move on to example 3. At this point, if you understand what to do and you know how to manipulate the equations and graph them, you can go ahead and start working on the rest of these notes and then just check your answers as you go. So I'm going to go through this next one a little bit slowly, and then I'll start going through them a little bit more quickly. Okay, so this first equation, we need to turn it into slope-intercept form. So I'm going to subtract x from both sides, because remember, slope-intercept form is when you're isolating the y. So I end up with 2y equals -x plus 6. And I need y by itself, so I divide everything by 2. So I have that equation. So I'm going to graph that line. plotting a point at 3 on the y-axis, because it is my y-intercept. And then I plot a slope of -½, so go up 1 and to the left 2, or you could go down 1 and to the right 2. Okay. Okay. I am now going to turn this next equation into slope-intercept form. Again, moving my x over. Now I have a -2y equals -x plus 1. Now I have to divide everything by a -2. Now I will say a lot of students forget that negative right here. Okay, try to be conscientious of where your positives and negatives are. So I end up with y equals 1/2 x minus 1/2. Oh, this is an interesting one. Okay. Hold on just a second. I think I changed this on our original notes. I'm going to pause for just a second.